guys, so today we're going to be covering some descriptive statistics extra examples from your Math 123 class. So the first problem that we're going to do here has a data set that represents the number of people in each car entering a park for a randomly selected group of 15 cars. So our data set looks something like this. And anytime you want to do some kind of data analysis where you want to find mean, median, mode, all of that good stuff, the first thing that you want to check is to make sure that your data is in order. Now, it's pretty clear that our data here is not in any kind of order. So what we're going to go ahead and do is rearrange our data. And when we do that, it looks something like this, okay? So we have a couple ones and then a couple twos and so on. My recommendation is to make sure that you count your numbers before and count the numbers after to make sure that you didn't miss any numbers. Another good idea is to write them directly under the original numbers so that you can kind of keep track of all of them and cross them out as you use them. It's kind of a common mistake to make on a test or a quiz would be maybe to forget one of the numbers. So the first question that we want to answer is which value is the mode. So if you remember from class, we talked about the mode as the most occurring or the most often used number. And if you take a look at the numbers that we do have a few values that are repeated. So for example, 1's used a couple of times, 2's used a couple of times, same with 4. But if we look at 3 occurs 5 different times in our data set. So that is definitely going to be our mode here. Now, the next question is to find the median, and in order to find the median, all you're going to do is make your way to the middle of the data set. So basically, you're going to cross off the lowest value, the highest value, lowest value, the highest value, and so on. And I believe when you do this, and you can go ahead and pause the video and give it a try, I believe when you do this, though, you should also get a median of 3. Now, last question would be the mean, and again, this would be a good place to maybe pause the video. In order to calculate mean, if you remember, we add up all of our observations and then we divide by the number of numbers. So in your case, you're going to be dividing by 15 since we have 15 observations, but you're just going to add everything up and then divide by 15, and I believe you get an answer of 3.4. So this last question just asks if the data is skewed left, skewed right, or symmetrical. So now that we know what the mean and the median are, we can compare them using the rules that we talked about in class in order to determine if our data is skewed or not. So it's pretty easy to see that the mean is larger than the median. And in this case, we can see that our arrow is pointing to the right, so this would indicate that our data is skewed right. Now, you could certainly make a case for the fact that 3 and 3.4 are pretty close to each other, so they're approximately the same. So our data could possibly be symmetrical. I could see making an argument for that. When we go to this next slide here, though, we're going to see an extra kind of way of visualizing our data that will help determine if it is indeed skewed right or symmetrical. So the following graph that we're going to look at is called a dot plot, and what it shows is the distribution of the data set from the previous slide. And what we want to kind of answer with this dot plot is whether the graphic agrees with what we determined on the previous page, meaning is it skewed, is it symmetrical? So if we take a look at this graph right here, this is showing the number of people in a car entering the park, and there's basically just one dot above each observation. So you can see that there are 5 dots on top of the number 3 because there were 5 cars there. We can also see from this dot plot that the 3 is our mode because it occurs most frequently. And if you were to imagine basically taking like a smooth line and kind of connecting these dots, you would have something that looks kind of like this, okay, and there'd be a little tail off to this side. So that looks kind of like this graph that we saw in class, and this is skewed right, okay? So there are basically fewer cars that hold a lot of passengers, and there are kind of many cars that hold between 1 and 4 passengers. And this kind of agrees with what we saw on the previous page. We decided that based on our data, the mean, if we look back for a minute, our mean was larger than our median. So our data was skewed right, and the dot plot does confirm that. Now let's take a look at just one last example here. So let's look at the following data set. It has winning race times for the last 9 Indy 500 races. And times are all rounded to the nearest minute. So this one has 9 values ranging from 160 all the way up to 209. And the nice thing we might notice about this data set is that it's already in order, so we don't have to worry about ordering things. So what we want to do here is we want to go ahead and find the mean and median and then compare them. We're able to kind of determine if there's a skew based on those values, and then we're going to answer just kind of one other question here. So you might want to pause the video, take a minute to calculate your mean and your median. I'm going to show them up here though. The mean, meaning when you add everything up and divide by the 9, because that's the number of numbers you have, you end up with 183.89. And this is actually smaller than the median. The median, which is your middle number, is 186. So since the mean is smaller than the median, this would indicate that our data is skewed left. Now, there's one other question that we kind of want to answer here, which is if the smallest winning time, so if the 160 were changed to an even smaller number, would the median change, and if so, how? So if you can imagine for a minute, you can kind of pretend you could take that 160 and maybe change it to a 150. And if you recalculated the median, what you'll notice is that it's not going to change. So the smallest number is immediately eliminated when you find the median, because the first thing you do when finding the median is you cross off the lowest and the highest. So the median does not change at all. But in terms of the mean, if you went ahead and you changed that 160 to a 150 or something even smaller, what you would notice is that when you add up all of your data items, you get a smaller number. So the mean overall would decrease. So the median does change, but the mean does not when you change kind of the outline data points, the largest or the smallest ones. So that's it for these couple of problems. Just wanted to give you a couple extra examples that go through some of this descriptive statistics stuff.